Hello and welcome to the Daily Space for today, April 4th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Today is a bit of a weird day. We are doing this at a completely unusual time. So if you meant to catch this live in, 40 minutes and instead you caught a rocket launch, well, the reason we're going live is rocket launch. So hopefully everyone will be able to find this when they want to. So we have so many things going on today. We started the day with a launch of a Progress capsule on a Soyuz rocket from Baikonur in Kazakhstan on its way to the International Space Station. It then docked with the International Space Station at the same time that it was doing that. The Space IL Bereshit lander transitioned out of orbit around the Earth into orbit around the Moon. We are now gearing up for the launch of a communications satellite on board another Soyuz rocket, this time launching from French Guiana, and this is being launched on behalf of Arianespace. But that is not all that is going on because, well, even though everything's launching and landing, that doesn't mean the science stops. In fact, the science just keeps going on, as do other random announcements. You may notice over here, I have a graphic up advertising a upcoming event. 3,650 podcasts later. This is going to be a 10-hour stream we are doing on April 27th to celebrate that we've been doing 365 days of astronomy for 10 years. You are all invited to join us. And if you are one of the many people who have streamed over the decade with us, please reach out. We would like to have you on. We're trying to get as many former podcasters as possible to participate in this event. Now, there is still so much more science going on, so much going on. The next thing I want to call your attention to is the dark energy spectroscopic instrument, which is called DESI. It is mounted on the 4-meter telescope at Kitt Peak National Observatory. This is the Mail telescope. It has had first light. This first light gives us a false color image of the Whirlpool galaxy, which is kind of cool on its own. But the thing that's really cool is not that we have this new image of the Whirlpool galaxy, but rather that this proves that our new instrument is going to have fabulous high-resolution capabilities of seeing the sky. And the reason that we need this is this particular instrument has 5,000 fiber optics robots that are capable of deploying fiber optics all across the field of view so that we can get all sorts of spectra of objects near and far. Take everything you know about the Sloan Digital Sky Survey and scale it up to an even bigger system, and you start to imagine what is going to be possible with DESI. Now, the reason that we're doing this is so that we can get the most accurate map of the rate at which objects near and far are moving away from us due to the expansion of the universe. We are looking to measure that expansion as a function of time, and this will also help us understand where's the dark matter, how's it acting, where is it behaving, in what way. It's a brave new future. This is one of many instruments that are coming online all around the world to help us explore that dark energy that was discovered back in 1998. This really gives you a sense of how long it takes to go from discovery to, well, instrumentation being completed. Apparently the answer is 31 years. So, wait, did I math that right? No, I couldn't have mathed that right. 21 years. So dark energy is now old enough to drink. Let that sink in, or at least the journal articles are. So, with DESI, along with the dark energy experiment down on the Hobby Eberly telescope, and hopefully with the upcoming W1st mission, we are going to map out great distances in great detail all across the sky so that we can better understand this universe. Now, moving to other parts of the cosmos, there are new simulations coming us from the National Astronomical Observatory of Japan. Sorry, I was getting all of those words jumbled. There are new discoveries coming to us from the National Astronomical Observatory of Japan. These are not observational results. This is a artist's rendition of a simulation that was done in a computer. And what the simulation is showing is a jet emerging from a core collapse supernova. This means that there was a massive star, something 10 or more masses of the 10 or more times the mass of the sun, that didn't undergo significant mass loss, or just started out so big that the mass loss didn't matter. And as it hit the point that it was no longer capable of generating light and energy in its core, all the outer layers of the star that had previously been supported by light pressure came crashing down. And as it came crashing down, there was a massive explosion, and the entire system, as a slowly spinning large object became a small object, conservation of angular momentum required it to start spinning faster. All of these processes also led to the creation of jets. Now, these jets of particles, as they streamed out the poles of the supernova in the simulation of the National Astronomical Observatory of Japan, as these jets emerged in the simulation, they interacted with the photosphere of the star and the surroundings. And it is believed that it is at this interaction between the photosphere and the jet that gamma ray bursts were created. So we are now starting to get fine-tuned models that help us understand the brightest events that occur in our universe. When these gamma ray bursts go off, we get a massive stream of light spanning all the colors of the rainbow and beyond, where we are seeing this in gamma rays, X-rays, optical lights, and if we keep looking, we're going to see it in radio as well. And sometimes we even start catching it in particles that hit our planet Earth. Now, this is cool. This is a case of we had the observations, we thought we knew what was going on, and we were able to make our theories match reality deep in the heart of more than one supercomputer. This is massive computations involved. So cool. Now, returning back to my happy place, which is observational astronomy. This is a new super high resolution image of Cygnus A, a nearby active galaxy. And this particular galaxy is about 760 million light years from Earth, which in the grand scheme of our universe is not that very far away. And this particular galaxy harbors a supermassive black hole in its core that is 2.5 billion times the mass of our sun. Now, this massive black hole, which I described as being part of an active galaxy, has a disk of material spiraling around it. That's the disk that you see. Oh, still learning how to green screen. Right there. That is the disk of material. That disk of material that is going around and around that supermassive black hole is filled with charged particles that are generating a massive magnetic field that is in turn generating jets. Now, we knew all of this from models. We knew all of this from kind of good enough observations in the radio. Well, this is the best images we've ever had and it confirms all of our theories. Now, what I particularly love about this radio image is you see these two bright inner jets. This was imaged, sorry, not with the VLA, but with the VLBA, the Very Long Baseline Array. This is where they combine a bunch of different radio telescopes scattered across the planet to synthesize a significantly larger telescope with significantly higher resolution. Now, up until next Thursday, or Wednesday rather, up until next Wednesday, this is going to be the highest resolution image we've ever gotten of the area around a supermassive black hole. And it confirms some of our theories. Where we see those two red inner jets, that central part, where it's no longer red, that was admittedly removed to stop hiding faint structure rather. But it also is part of depicting how the torus is in there. There's a donut of material, that accretion disk that I mentioned. And you see that labeled as a torus in this image. So the system that we're looking at, we essentially have a disk of material seen edge on with jets coming out either side, and where those jets meet in the center is getting blocked by that torus of material. This is just awesome. This is simply just awesome. Now, the reason that I say this is the highest resolution image of a supermassive black hole that we're going to have until next Wednesday is because next week we are going to have the release of the Event Horizon Telescope's image of our own Milky Way galaxy's central supermassive black hole. And as was explained last night on the Weekly Space Hangout by Fraser Kane, if you were to try and repeat an image of this high of a resolution, you would need the ability to resolve someone on the International Space Station holding 17 tennis balls in a very tight-knit line from the surface of the Earth. So if your telescope is capable of resolving an astronaut with 17 tennis balls, you're capable of getting the same kind of resolution on the sky that was achieved by the Event Horizon Telescope. Now, the Event Horizon Telescope isn't a physical telescope. You can't go visit it. It's in no one single place. What was done was a whole variety of radio telescopes spanning the globe and above the world on orbit were all brought together and asked to observe our own supermassive black hole all at the same time. This is the same technique that was used to get this image. And the reason that this is able to work is with radio telescopes, you have the ability to actually see in your detector the peaks and troughs of the radio signals as they come in. And by knowing how the Earth geometry is set up, knowing the differences in distance between each of your telescopes and that distant object that you're trying to observe, you can shift the time in a large computer of when synthetically all those radio signals arrived. So if you have one telescope that, because of where it is on the Earth, the geometry works out that it's a little bit closer to the object than another telescope, well, you adjust the timing of when you're looking at this signal and when you're looking at this signal so they seem to be the same distance. And when you get all of these radio signals lined up just right, it acts as though all of these telescopes were a single telescope observing simultaneously. The process that you use to do this is called fringe finding. It's a bit of a bear because it relies on all of the signals having accurate clocks, and that's not always the case. So a little bit of futzing is required. And in addition to having to futz to actually get everything to line up correctly, this one was also complicated by the fact that one of the telescopes they used is in the South Pole. So they had to wait for the weather to get better before they could go get the physical memory stored information and bring it back to where all the data was reduced. We will be bringing you the press conference associated with all of this live next week right here on twitch.tv/CosmoQuestX. Now, one of the things, and I'm going to switch views to keep reminding you about our upcoming April 27th stream. Now, one of the things that I had mentioned that I was going to try and do is folks had asked if we could record, if we could stream live on YouTube, and I figured out the technology to do that yesterday, but it was pointed out that our agreement with Twitch doesn't allow us to stream live on multiple platforms. We can only stream live on one platform at a time. And this means we're going to continue to go live right here on twitch.tv/CosmoQuestX, but we will also continue to archive all of our episodes over on YouTube. Now, I noticed that a bunch of you are doing the completely sensible thing of subscribing to the user CosmoQuest over on YouTube. Now, because of the history of Google Plus and CosmoQuest, it turns out that all of our videos are tied to our Google Plus account, which has a different URL than our CosmoQuest user. One of our volunteers and employees, depending on what task she's doing, the fabulous Nancy Graziano, who's the founder of the Weekly Space Hangout crew, our fabulous sister community, support community. She is trying to figure out, thank you, Uncle Bill, for the sub. Let me see. I think I have dogs up here. Do I have dogs up here? Thank you, Dave Killians, for the sub over on YouTube. I know you subbed on YouTube because I have those notifications turned on now, but I don't have them configured. So thank you for subbing on YouTube. And I have very sleepy dogs that I'm going to hurl Cheerios at. My dogs are not as interesting. Did you hear this? Do you want this? Okay, let's see if that gets them slightly more excited. So thank you so much. So we would ask that you please sub to the CosmoQuest channel that has more than one video. That should be your hint that you're in the right place. So thank you very much, those of you who do sub over on YouTube. YouTube subs are completely free. And if you notice, I have a slightly different home with a box that I'm still learning how not to take my hands out of here on Twitch. And this slightly new layout is we're testing new software called Wirecast. Let me know if you see any problems. Let me know if you see anything you don't like, and I will work on getting everything just right. Now, the other thing you may see is right now over there, I have goals. I have goals. And this goal is our goal so that I can pay Annie for everything she does on this channel. Because she spends a lot of time prepping and setting up and helping out and streaming all the things. And this is the budget we need with overhead and benefits and insurance and all that sort of stuff to pay her for the work that she's doing. Thank you, Bensai and Games, for subscribing over on YouTube. Thank you so much. And I will fix all of these graphics, I promise. This is how much we need to make this month in order to feed Annie. We are really good at feeding our dogs because of you. Help us feed ourselves. Okay, I am done with the begging portion of the show. I am now going to do my standard station identification and answer your questions until we head over to covering Ariane space in If we aren't switching back over to Annie, I'm going to need a URL. I think we may be switching back over to Annie because honestly, she really knows the launches better than I do. Okay, so here we go looking at the questions. I don't have bacon to throw, and if I had bacon to throw, I would not throw it, I would eat it. Okay, we are going to switch. Thank you, Annie. Thank you. Thank you. Okay, so looking to see if we have any questions. Scrolling up, scrolling up. I need to switch which screen my questions are on so that I'm not looking off the side of the screen. Okay, scrolling up. Hello, Michael. Yes, 5,000 fibers on the dark energy dark energy spectroscopic instrument. DESI. Let's just go with DESI. And more to the point, they're robotic. So there's like little hands in there that can move them around so that they're lined up on all of the stars. This is one amazing piece of instruments. And thank you for the rating party, Ben. I didn't notice that earlier because we were in the process of switching hosts. Thank you so much for the raid. Welcome new people. This channel does a whole variety of different shows. I totally failed at my station identification. I said I was going to do one, and then I didn't. So station identification. My name is Dr. Pamela Gay. I am currently your host right here on CosmoQuest X. We are your place to learn and do science. Somebody made it rain. Thank you for the donation, Veronica Cure. Thank you so much. We are a production of the Planetary Science Institute, a 501c3 nonprofit, which means your donations are tax deductible where the law allows. We are working in collaboration with Youngstown State University, and I've been working on some super secret projects with OSIRIS-REx in the background that Keeper of Maps actually found discussed on a Russian web news site. We are working on the software that's currently being used for site selection for the rock that OSIRIS-REx is going to snag and bring home. So I can now tell you the delays in why we've been so slow relaunching the CosmoQuest Citizen Science sites are because we've been writing software for a spacecraft team and they're happily running on their own software. It's not citizen science, it's the science team. We will be mapping Bennu, doing citizen science later, but first we just need to survive the encounter. So we are your place to learn and do science, and I can't wait to get you doing science again. Okay, let me see if there's more questions in here. Thank you, Mythtown, for the bits. Thank you. Eddie's right here. He's like, if I come closer, will the Cheerios come out closer? It's like, no, that's not how it works. You have to stand up and go over there. Eddie, see this? Go over there. Okay, Eddie isn't the smart one. He's just fluffier and cute. Yes, Michael, you do have to allow for all the different Doppler shifts. It's recombining the data when doing radio interferometry is a trickstery form of science. There's been many mistakes made over the years. The first not actually a planetary planet detection was around a radio visible pulsar. And the reason that it wasn't real is because they forgot to take into consideration the Doppler shifting of the Earth as the Earth orbits the sun. So they had a 6-month alias in their data. Yeah, it's trickstery. But over the years, we've gotten good at it. But it did take them a long time to reduce the data because sometimes you need to do it more than once to get it really to come out good. Thank you, Jam8 Bieber, Jam 8, a Reaper, for gifting a sub. Thank you so much. That's awesome. Okay. So the semi-transparent hair is actually a hair dye that faded from blue to green because that's apparently a thing. And I also have my shirt going transparent periodically. This is because I have green hair, and I was looking at that earlier today, and I will be dyeing my hair, so this is no longer an issue. It's simply that there's too much green in my hair. So yeah, I have semi-transparent hair currently because there's green in it, and I have a green screen, and these are things. Thank you. Okay, so Astro YYZ writes, any speculation on the bright new object in the image of Cygnus A, i.e. the bright blob at around 4 o'clock in the image? So let me bring that image back up. This is going to take me just a moment. It's going to take me just a moment because I'm trying to remember which things to click. There we go. So the object that Astro YYZ is pointing out, I can't get my finger there without cutting it off on the side of the screen, is that almost perfect rainbow colored circle. It is simply labeled bright new object discovered in 2016. We're still trying to figure that out. It could easily be a foreground or a background object. I don't know the details. It's cool. But the sky is filled with radio sources. And one of the issues that I ran into, because my doctoral dissertation was actually trying to find a new way to find galaxy clusters more effectively. And what I actually did was I found a way that if you spend 4 times longer computing potential places to look, you can increase your probability of finding them about 4%, which is not useful. And it was like from 23 to 27%. So it was all kinds of not useful. And the reason the technique I was defining wasn't useful is if you look at any one radio galaxy, there is a high likelihood it's going to be in a galaxy cluster. So we have amazing all-sky surveys in radio. So point a telescope at one of those radio galaxies, look around at an optical, and you may find a cluster. In fact, about 23% of the time you find a cluster. So what I theorized would work was if you looked at clusters of radio galaxies, you would increase your probability of finding galaxy clusters, and you'd probably be finding a slightly different population of galaxy clusters. What I actually found was most of the time when you do that, you find 2 clusters lined up on the sky at 2 completely different redshifts. So I was basically looking down the walls of the large-scale structure of the universe. Radio sources come at all distances and often overlap on the sky, making things very confusing. So I am one of those people that did completely reasonable research with a completely non-sexy result. Okay, so Annie, we're going to need to switch over to you pretty soon. We are coming up at a few minutes away from a Ariane space launch of a ComSat. Okay, so to continue our tradition of awkward credit rolling, I'm going to roll the credits once, transition over to Annie, and I still don't have music for doing that, but I'm going to roll them once without music. Hum along to yourselves, and I will see you on the other side.